Alrighty, with this question, we have a cone, which is made from this sector over here. So we've got the radius, we've got the angle, theta. So find correct three significant figures. A slant side S, so that S side. Okay, so as you can see, I can see a bit of a right angle triangle. So I'll draw that for you. So that's what I'm trying to find. I know that my height's 10 centimeters. My base is half of 12, which is 6 centimeters. So I could just use Python. So my S is going to be square root of 10 squared plus 6 squared. So let me figure that out in, excuse me, three significant figures. So I get 2 square root 34, which is approximately 11.7 centimeters. Okay, so A is done. Let's try B. The value of the R. Well, if I have a look here, it's actually the same as the S from what I see. So if I kind of unravel this, that looks exactly the same as my R. So I'm just going to assume my R is the same. 11.7 centimeters. I might just quickly double check the answers with that. I don't have my answers up. Okay, we're just going to keep going and hopefully it's right. C, the arc length of the sector. So the arc length is this length. I need to figure out my theta first of all. Okay. Well, my arc length, let me just see if I can write my equation. Arc length is L equals theta R, or theta over 360 2 pi R. So we're doing radians, it seems like, so I might just use the radians one. So arc length L equals pi R. So arc length, I don't know the theta at the moment. Let's have a think. Interesting. Radius is 11.7. Length we don't know. We know that the diameter is 12 centimeters. I'm a little bit stuck. D, sector angle theta in radians. How do we figure this out? Arc length of the sector. There must be a way. Let's have a think. Well, do we figure out this angle maybe? And then because if I do that angle, that'll give me a portion. I guess if I figure out that angle, interesting. Well, I'm going to try to figure out that angle. Let's see what happens. Maybe I could just use my cosine rule. Tangent rule. Tan theta equals opposite over adjacent. So tan theta equals 6 over 10. Theta equals inverse tan 6 over 10. So my answer's in radians. I don't know if I want it in radians. I might change it to degrees. So I get 30.9 or 31.0 degrees. Or in radians it was 0.54 in radians. Arc length of the sector. Surely there's a way to figure this out. Well, I think I know how to figure it out. So basically, it's that arc length should be the circumference of that. The bottom circle has a radius of 6 because the diameter is 12. Okay, I'm assuming this is right. So that took me a little bit, but that's okay. So circumference is 2 pi r. Why did I not think of that? 2 times pi times radius. So 2 times pi times 6. 12 pi, which is 37.7 centimeters. Okay, that's much better. Alright, now we can figure out, sorry, that's still C. D, now we can figure out the sector angle because we know that length, which is this arc length, can also be found as theta r. We know the arc length 37.7 equals theta, and the radius that we used in that example is 11.7. So if I rearrange that, I should get 37.7 divided by 11.7. Oh, too many sevens. Okay, so I get 3.22 radians. So hopefully that's right, the answer. I'm going to go check it.